Hello, beautiful people. Feature me. Welcome to another programming work of mine. I will be typing for 5 minutes, hopefully improving it, and then I will do 25 minutes of some coding exercise. Let's get into it. Hmm. Right in time, I would say. So, what is the result? 5%. Well, good. Keep it going. Keep it going. Okay, let's continue in the other practice. The other part is to one of those. I was doing this, 94, 91 is less, so we'll do SQL. It's not ready? Oh, crap. Okay, so Typescript, do we have something in Typescript? We do, okay, good. Assertion functions. Let's go. An assertion function throws an error unless some condition is true. We'll start by defining the basics form below. In these examples, you can type error if an example will cause a thrown error at runtime. When this assert function doesn't throw an error, it will return undefined. So if condition throw error, okay, so that is just a normal function. That is not a keyword or anything, right? We just have a function. We named it whatever. In this case, it is assert. We can throw error. If we don't, it returns undefined. Okay. So assert. So this is defined, and this is error. This function guarantees that the condition is true. We can tell that by looking at it. But the TypeScript compiler doesn't know that. What happens if we call assert type of blah blah blah, as an example below? The code after that point will only run if assert didn't throw an error. That means the var1 must if actually been a number. TypeScript doesn't know that. It still thinks it is a union type of number and string. When a code example has a type error, I can type type error. Okay, so this is a type error. Remember that we can narrow types by using if, yeah. If in the next example, we narrow a variable's type from number union string to just number. The TypeScript compiler allows this because it knows that var1 has the type number inside the if. So variables 2, so we put in 1, so we will get 1. TypeScript 3.7 allows assertion functions to narrow types. Narrow types, I love not this music. Need to change the music. Insertion function to narrow types is kind of like how type guards narrow them. It requires one small tweak to the assert function. We'll tell the Typescript compiler that what we already know. If the assert function returns at all, then condition that we passed it must be true. Okay. In this example, note that asserts condition new asserts condition syntax. It's referring to condition the argument to the function. Okay, so asserts condition. Okay. Asserts condition is the thing with that one tweak. Or assertion function can narrow types. Can narrow types. The next example doesn't pass a type error. This music is distracting me. I have to. Next example doesn't cause a type error. The assert type of one number call narrows. Okay. Oh, I see. I see. So this one will get us that sync. It asserts it, and here it says asserts condition. Okay. As always, the narrow type is enforced. The narrow type is. It's a little bit confusing because it takes like value, which is a boolean, and then it does not take the value, but it actually looks what it was, and something different to compare what I've seen here in the JavaScript and TypeScript so far. Oh well, as always, the narrow type is enforced. So trying to violate it is a type error. So And is yeah, so it's a type error. Our assert functions type included assert condition, where condition was an argument to the function. Yeah, that was, yeah. Unfortunately, we can't put an arbitrary Boolean expression after asserts. It can only accept a single argument name. For example, we can't write an assert false function that declares assertion, asserts not condition. That would be a syntax error. Okay, when a code example contains a syntax error, you can, yeah. So this is syntax error. Why is this a syntax error and not a type error? A type error happens when the code structure is legal, but the types don't line up. The exclamation mark in above example is completely illegal. A exclamation is never allowed after the assert keyword, regardless of the types. In the example above, the type checker never even gets a chance to run. Assertion function can also tell the compiler what a value that a value has a specific type. For example, we can write an assert number function to simplify the type of var1 triple equals number. Strictly checks in our previous examples like before, it will narrow the type of its argument. Assert number function to specify type of word. Okay. In this example, note the asserts arc is number. Asserts arc is number. That's similar to the syntax that we saw for type predicates in type guard functions. In a type guard function, we weaved wheat 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 we say arc is number. The difference here is that we add asserts on the front of what? So assert number, okay, and a non asserts n is number. Ah, okay, so we specify that, and previously we assert condition. And here we say n is number. What else can I do this? Like n is greater than something. Can I have here an expression? How does that work? The next few examples show the effect of our assertion function. Be careful. One of them has an intentional type error. You should answer type error. At the runtime error, you should answer error. Okay. That will be the exclamation mark, I suppose. So we have a number or undefined. It takes number. So, and this is a type error. It was easy. Here const n points to number or and type is unification of number undefined. It returns n. Then we are asserting for it to be a number. So this will be okay, I believe. And now we have this is undefined, so this will blow up on assert number. It will throw an error, so I will type here just error. Okay. What else? Our assert number function's argument has the type unknown because it could be any type. The reasoning is the same as it was for type guard functions. We can't make assert number take an argument of type number. Then it would never do its job of throwing an exception when, yeah, that's logical. We will complete something, write an assertion string assertion function. Make sure that its argument has type unknown. Okay, so as unknown, then we will say asserts or assert? Asserts. It has to be a red, and that we will do like this, and we will say s is string, I think. And there was a red, was it red? No, it wasn't. Okay. The s is string, and here we will have if type of s is not equal to string, we will throw an error. Error. Boom. Like so. Close this, and it should be okay. Syntax error, comma expected, where okay, so maybe I should, no, that is okay. Function assertion, oh yeah, I did not specify the type properly. The s unknown on the line, on the first line, like so. Now it works. Type guards and assertion functions are very closely related. The difference is in the scope of their type narrowing. Type guards and assertion functions are very closely related. The difference is in the scope of their type. Scope? With a type guard like if, yeah, so it will be in the if body. It's narrowed only inside the block, yeah. With assertion function like assert number, the type of X is narrowed for all code after the assertion call. Good you said it, that was something I was assuming. The compiler has no way to verify or assert declaration, so it has to blindly trust them, just like it blindly trusts our type guard functions. That makes asserts more dangerous than other parts of the type system. Be careful with this next example. It's intentionally wrong in a way that the type system can see. The assert number function is implemented incorrectly. It accidentally checks for a string type rather for a number type. A Typescript can see the mistake, so this code compiles and runs, returning a result that violates the state types. So it says it is a number, but it's really, if it's string, it will pass. So this is a string. We will assert it's a number, that will be okay. We will assert, the n, that will allow n to point to the string, and we are in big troubles. And when we print out n, we will get a string. Our suggestion here is the same one that we made for type guard functions. Write some extra automated tests to be sure that your assertion functions do what you think they do. And I'll finish the lesson. Okay, you have 2 minutes to go. Sure, why not? Some functions never return. For example, a function that always throws an exception never returns. Oh no. Yeah. What should this function's return time be? Void? Typescript will infer it have to be return type of void, but doesn't fully capture what's happening. Is it not? The void type is for functions that begin, do some work and finish, but don't return a value. Our functions above is different. If we call it, then the code after that call will never execute at all. Ah, I see. Fortunately, there's a TypeScript type for that. Never. There was never. Okay, that's interesting. So that's interesting. The never type is a bit strange. It's assignable to any other type. We can assign it to a number variable. For example, the function will continue to throw the exception like usual. So the answer here is the same above. When code will result in an error thrown on runtime. Okay, so never number throw. This is okay. So it will be, oh no. No, I thought you can. We can assign it to a number variable. At first, it seems like never is acting like any, because we'd allow to assign it the never to a number. or a string or anything else, but unlike any, this is safe. The compiler knows what that our throws function never returns. And we are out of the time. So that means we are done. Done is better than perfect. And I will see you next time. Bye.